This planet is eating 6 billion tons of material every second. No, seriously. This one is a rogue planet, meaning it doesn't orbit any star. It just drifts alone through space 620 light-years away. And this year, astronomers watch it go on an absolute feeding frenzy. It's sucking up gas and dust from a swirling disk around it at 8 times its normal rate. This is the most intense accretion burst ever recorded for a planetary mass object. And here's the wild part. It's behaving very much like a baby star, not a planet. This thing is blurring the line between planet and star formation. Some scientists think it might even form its own mini-solar system out there in the void. A planet with no star, creating moons orbiting around it. I'm talking about CA 1107-7626, a planetary mass object that isn't officially classified as a planet yet. But for simplicity, we'll call it a planet throughout this video. In this video, we're going to explore why this cosmic orphan is forcing astronomers to rethink how planets form, what triggered its unprecedented feeding frenzy, and what it means for our understanding of how worlds come to be. Before we dive deeper into our hungry wanderer, let's talk about what makes a planet rogue in the first place. Every planet you've ever heard of orbits a star. Earth circles the sun. The gas giants in our solar system follow their predictable paths. Even the most distant exoplanets we discovered are gravitationally bound to their host stars. Rogue planets. They broke free from that system entirely. They are cosmic nomads drifting through interstellar space with no star to call home. Now, how does a planet end up like this? Scientists have 2 main theories. The first is the ejection scenario. Picture a young planetary system, chaotic and violent, where massive planets gravitationally interact. One gets too close to another, and like a cosmic game of billiards, it gets flung out of the system entirely, sent tumbling into the void at incredible speeds. The second theory is more intriguing. Maybe they never orbited a star to begin with. Maybe they formed in isolation, collapsing directly from clouds of gas and dust, just like stars do, only on a much smaller scale. Here's the challenge, though. Finding rogue planets is incredibly difficult. They don't reflect starlight because there's no nearby star to illuminate them. They are cold, dark, and hiding in the blackness of space. Astronomers had to use clever tricks like micro-lensing, where the rogue planet's gravity briefly magnifies the light from a distant background star, creating a telltale spike. Or they use infrared surveys, picking up the faint heat these worlds still radiate from their formation billions of years ago. Despite the difficulty, we found them. And CA 11107 is proving to be the most fascinating one yet. So, let's properly introduce our subject. KA 11107 sits about 620 light-years away in the constellation Chameleon. To put that in perspective, if you left Earth today traveling at the speed of light, you wouldn't arrive there for over 6 centuries. It's distant, isolated, and until recently, relatively unremarkable in the catalogue of rogue planets. But size-wise, this thing is a beast. We're talking 5 to 10 times the mass of Jupiter, which itself is over 300 times more massive than Earth. This isn't some rocky world like ours. This is a gas giant on an epic scale. A massive ball of hydrogen and helium floating alone through space. Here's what makes it special, though. It's incredibly young, between 1 and 2 million years old. In cosmic terms, that's practically a newborn. Our solar system, by comparison, is 4.6 billion years old. This planet is still in its infancy. It's actively growing, actively evolving. Surrounding this rogue planet is an accretion disk, a flat rotating disk of leftover gas and dust from the planet's formation. This is totally normal. Young planets and stars alike have these disks. Material slowly spirals inward over time, gradually adding mass to the central object. It's a slow, steady process, or at least it's supposed to be. In early 2025, astronomers monitoring CA 1107 noticed something was happening. The accretion rate, the speed at which material was falling onto the planet, started to climb. Not dramatically at first, just a noticeable uptick. Then by August 2025, it exploded. The planet was suddenly devouring material at 6 billion tons per second. To give you a sense of scale, that's roughly equivalent to consuming the entire mass of Earth's atmosphere in about 2 weeks. 6 billion tons every single second. The accretion rate had increased 8-fold in just a few months. What had been a gentle feeding process turned into an all-out cosmic binge. And this wasn't just impressive by planetary standards. This became the strongest accretion episode ever recorded for any planetary mass object, rogue or otherwise. Nothing we've observed has fed this aggressively. So, what's driving this? The mechanics are fascinating. Magnetic fields threading through the accretion disk are playing a crucial role, funneling material inward along specific paths. Think of it like a cosmic funnel, channeling gas and dust directly onto the planet's surface through magnetic field lines. The geometry is complex, the dynamics are intense, and the result is this unprecedented feeding event. But here's where it gets really weird. During this burst, the chemistry of the accretion disk itself changed. Water vapor appeared in the disk spectral signature. New molecular compounds emerged. The disk wasn't just passively feeding the planet anymore. It was chemically transforming in response to the burst. And that's behavior typically seen in young stars. When stars form, they go through exactly this kind of episodic accretion. Young stars don't grow smoothly. They have bursts, dramatic events where material suddenly pours onto them at accelerated rates. We've observed this countless times with baby stars. It's part of the star formation playbook. Disk instabilities, magnetic field dynamics, sudden feeding events, chemical changes in the disk. But Ka-1107 isn't a star. It's not even close to being massive enough to sustain nuclear fusion in its core. It's firmly in the planetary mass range. Yet here it is displaying behavior we associate exclusively with stellar formation. This is blurring a fundamental boundary in astronomy. For decades we've drawn a clear line between how planets form and how stars form. Planets we thought coalesce inside protoplanetary disks around existing stars. Stars collapse from molecular clouds and build up through episodic accretion. 2 different processes, 2 different environments. CA1-17 is challenging that distinction. It's suggesting that at least some rogue planets, especially the massive ones, might not be ejected planets at all. They might form through the exact same process as stars, just on a smaller scale. The collapse of a gas cloud, the formation of an accretion disk, magnetic field interactions, episodic bursts, the whole star formation sequence just dialed down in mass. If that's true, then asking, is this a planet or a failed star, becomes a lot less meaningful. The formation processes aren't fundamentally different. They are part of the same continuum, just at different mass scales. And that has massive implications for how we understand the diversity of objects in our galaxy. As cool as all this is, we're left with plenty of questions that nobody can answer right now. But let's zoom out and think about the bigger picture here, because this rogue world is teaching us some fundamental lessons about the cosmos. First, it's forcing us to acknowledge that the neat categories we created for celestial objects, planet versus star, formed in place versus ejected. These categories might be too rigid. Nature doesn't care about our labels. Objects exist on continuums and formation processes blend together in ways we're only beginning to understand. Second, it's expanding where we think planet formation can happen. We've always assumed planets form in protoplanetary disks around stars, protected and nurtured in that stellar environment. But the rogue planet is showing us that planetary mass objects can form, grow, and evolve in complete isolation in the vast darkness between stars. That opens up entirely new real estate for planet formation across the galaxy. Third, it raises the possibility that there are many more objects like this out there that we simply haven't detected yet. Rogue planets in active accretion phases might be far more common than we realized. Future telescopes like the extremely large telescope currently under construction or continued observations from the Webb telescope might reveal an entire population of these feeding rogues, each one teaching us something new about how worlds come to be. And finally, on a more philosophical level, it's a reminder of just how diverse the universe really is. From scorching hot Jupiters orbiting dangerously close to their stars to frozen ice worlds in the outer reaches of planetary systems to rogue planets drifting alone and feeding on cosmic material, the variety of worlds out there is staggering. Our solar system, orderly and predictable as it seems, is just one tiny example of what's possible. Here's the question I want to leave you with. Is CA 1107 a rare cosmic oddity? A 1 in a billion fluke that we just happened to catch at the right moment? Or is it revealing a hidden side of planet formation that's been happening all along countless times across the galaxy just beyond our ability to see it? Drop your thoughts in the comments below. I genuinely want to know what you think about this. Thanks for watching, and I'll catch you in the next one.